evening, everyone. On behalf of the organizing committee, it is a great honor to welcome all of you to an exciting technical session followed by the IEEE Robotics Automation Society Sri Lankan Section Chapter in partnership with IEEE Sri Lanka Section. Robotics is one of the fastest growing fields, and it has reached some level of maturity in recent years. Artificial intelligence has been programmed into vacuum cleaners, non-humanoid personal assistants, and even into self-cleaning litter boxes. With the beginning of this new era, people start making lots of predictions on what would be the coming biggest advancement or the trend of the technology in the future. So you may already aware that the Internet of Things has been called next industrial revolution, and that will change the way of all businesses, governments, and consumer interact with the physical world. So we hope now it is right time to have an in-depth look at how to prepare for the robotics and industrial Internet of Things. And here Meetup will bring us an excellent forum to address this. So today's Meetup includes two valuable speakers along with the panel discussion. This Meetup will provide us not only essential knowledge, but also to share our experiences and technical development in the field of robotics. And so now, without taking much time, let me introduce our first speaker, Professor Rohan Munasinghe, who is the head of the Department of Electronics and Telecommunication Engineering of the University of Moratuwa. He earned both master and PhD degrees in advanced systems from Saga National University in Japan. He was a postdoctoral research fellow at Korea Advanced Institute of Science and Technology, which has been engaged in collaboration research with Stanford University on developing robot systems based on human skills primitives. His main teaching and research areas are robotics, control systems, unmanned aerial vehicles, and autonomous intelligence systems. He has served as the Director of Engineering Research Unit of Faculty of Engineering. He also been a consultant and a resource person to a number of government institutions, including Center for Research and Development, Ministry of Defense, Artistic Modern Technologies, National Engineering Research and Development Center, National Science Foundation, National Institute of Education, Sri Lanka Inventors Commission, and so on. So Professor Munasinghe is the present chairman of the IEEE chapter of IEEE Robotics and Automation Society, chartered engineer, senior member of IEEE member of Robotics and Automation Society. He is going to present a brief overview of robotics initiatives in Sri Lanka and some recommendations for the way forward as a developing country. So now I invite Professor Munasinghe to address the gathering. Thank you.
Okay, very good evening to all of you. Um, so it's a, I think, very important moment for IEEE Robotics and Automation Society chapter of Sri Lanka, and uh, all the other uh, people. I think you're very involved in the software, taking in software, AI, and related software. Robotics being a multidisciplinary application area is not a fundamental science like maths or electrical engineering or electronics, but basically application. I standing on a number of pillars. Therefore, has a share in this field robotics. So I thought of please cover this. So I thought of giving you a brief overview of what we are doing uh, in this field of study, the research and development. Um, but I don't think I have all the information. Therefore, I will basically presenting the works I have been engaged in over the last 10 or so years in Sri Lanka. And also I will show some of the things that my colleagues are doing. My colleagues basically from Toronto University. So therefore I have to accept the fact that there can be many other things that people are doing in Sri Lanka, basically Kerala, and maybe some people in UCSC Colombo, doing some great jobs in computer science related to robotics, but I don't have that particular details, so therefore I'm not going to present anything on those areas, right? Um, so till we get this fixed up, I can just share some other information with you. If you look at the future world over in robotics, we haven't put our country Sri Lanka on the map. Nobody can see the robotics per section. We don't even exist in there. Because there are so many areas in robotics, but without getting into what is called industrial robotics, we cannot make our presence in the global area. Industrial robotics is where you make money. All the other areas are fun for entertainment, for research, for our curiosity design and buildings. But until and unless you put it into practice, you cannot convert it into money and contribute to development of countries. So we have been pressing the government and other institutions. Okay, this is the technology of the future, robotics. Policymakers, ministerial people who have the authority to make a change cannot go on using technology in hand. Telling them, okay, there are four major technological areas. We call them green technology. G means genetics, R robotics, IT, and nanotechnology. So we have to pick up one of these things and focus hard and work hard on the development, and then only you can be an owner of the technology, and then you produce things that people can use in day-to-day life, or you can put them into hospitals or wherever service to masses of people, and you convert only that I. So otherwise, our future will be probably worse than today. Uh, uh, because all the other countries, including our neighbors, are moving forward with the new technologies, and we will find it very difficult to come back if we want that safely and quickly. So that is the background story, right? And I think somebody has to make a breakthrough and force our industries to use this technology because this is efficient, fast, and of high quality and of low cost. Then we can compete with the neighbors in the global arena. Right. So I will basically be talking about what we are doing in Sri Lanka, as I said earlier, in universities, in education, and in research, basically. I will not talk about industrial thing because I think probably Nalin will, no? But IoT, okay, right. So I will talk about along these lines, right? Robot manipulators, mobile robotics, rehabilitation, aerial robotics, and underwater. And as you can see here, none of these things can make technology into money. As I said to you, this is one of the problems. Universities cannot do that. In the commercial world, government has to make a decision and push the industries to use this technology. So let me start with the first one, robotics competitions in Sri Lanka. I think it's over here. Yeah. So we have introduced robotics into undergraduate programs. Most of you have gone through this process, but you never had a chance to enroll in one of these modules, robotics modules, right? I'm sure. Around 2006-07, those who have been in Moldova or maybe Albania, they also are having competitions in undergrad level. So what we are trying to do here is to ask the students to design and build fully autonomous robot, and we give the task what the robot is supposed to do, and they have to build the robot, the mechanical structure, the power system, the electronic system, the sensor system, and the algorithms. So if you all these pieces together in a nice, compact, and fun event in the university, and they learn a lot of things also. It's a multidisciplinary. We don't teach them theories in that level. We teach it in the lower semesters, but they learn a lot of things hands-on. And later, in their careers, in the final year project, or maybe even after that, they can actually undertake a lot of challenging problems. And I know most of our graduates passed out recently. They have done really well in this area in other companies, designing and building advanced robots. So let me show you some of these videos, what the students are doing. So they design and build small robots like this. So this one, this robot has to follow this line, black stripe on the white background, using array of sensors, and then detect the intersections, and then take the proper turns. And here at this junction, they have to make a decision whether to turn to left or right. The left-hand side is shorter, right-hand side is longer. And you select the shortest path because you want to get to the destination at the shortest time. And then if the block you are carrying is white, you have to unload it on that side. And if it is unloaded on the other side. And you have to come back and collect as many blocks as possible within a given time period. So this particular robot was probably the winner of that competition. Right. Then let me show you another robot that is 2012 competition, first place. So that year, the robots have to follow white line on black so they can invert the logic. That's easy thing. Um, they have got the algorithms pretty improved that when they follow the lines, they don't go sideways. They go to this piece, blocks in the reverse, and then load it onto a container here, and you can see the two sides. Two robots are competing each other. Eventually, telepresence robots is actually it's a continuity of communication over a distance. Like you can think about telephonic first, and then you have teleconferences. Right? You bring many people closer together, even though they are far away. And the next one is telepresence. So what is it? Um, this is one of the projects we did about 3 years ago. This is the telepresence robot. So the person that you see on here, right, is the person who's remotely logged into the robot, and he can drive the robot. It's not a teleconference thing anymore because you have this mobility at a remote place, and you can talk to your friend entirely remotely. So mobility added to teleconferencing, in other words. And also you can have a robot arm over here so that you can manipulate things remotely. And you can think about number of robots like this, located at different places that you want to meet people in, right? Then you can switch from one robot to another robot. And at a given moment, you are in Colombo, in few seconds you are in Delhi, in few seconds you are in New York, or wherever. If you have these robots ready to be used in those locations. So this is a new industry which is actually booming. Uh, Therefore, a lot of busy parents in the developed world, they have these robots at home to keep close contact with their kids at home because they are mostly flying and not in overflow. So, uh, so it is happening right now, uh, and I have heard that the surgeons, some of the surgeons, they are actually trying to get some of these robots into the theaters, right? So that if they stuck in traffic or anything, they cannot make it to the theater on time. They can at least log into these robots remotely while they're driving, right? Then give instructions, uh, not only by voice, but by manipulating certain things in the theater, helping out the other doctors who are performing the surgeries. And I think this robot, the KUKA, it is a mobile manipulator. You can see a manipulator over here and mobile platform here. So it's a combination of two different robots into one piece. So it increasing the number of degrees of freedom of the device. So, but it becomes extremely complicated when you have the manipulator and also moving uh, uh, with the mobile platform. So extremely complicated modeling and control, but it can do marvelous things. I think one of these robots are there in electrical department, Moreover, they're doing pretty, starting to do a lot of research on these manipulators. And you can see the names here, Dr. Buddhika, Dr. Chandin from E department, and also Dr. Peshal, who recently joined us at ENDC. He's also into mobile robotics. So we can see a lot of research in this area. Basically, as you have heard, SLAM, self-localization and mapping, where you send a robot with mobility to an environment which is unknown, and the robot has the sensors to actually take measurements of the environment and create a map. So that is mapping basically. And then after that, you have to localize yourself where you are within that environment. That is a very, I would say, difficult area in robotics. A lot of theoretical stuff involved in research, but it's very interesting. And also multi-agent systems in the same area, mobile robotics. We have a set of small Zoom robots like this, programmable devices, and you can have a number of these devices together as a team or group, and then see how you can optimize their performance, right? Teamwork, trying to achieve one single task. So these research are actually coming up in developments as model work. Then I know Dr. Gopal is here. He and Dr. Rajiv, they are into more into rehabilitation and prosthetic arms, kind of that area in robotics. They're trying to design and build upper arms, lower limbs, and things like that, and try to design these prosthetic devices. So that is a very interesting area in robotics, as you already know. And maybe next to industrial robotics, this is another area where you can make a lot of money out of it. You can design a very good, convenient prosthetic arm, maybe a forearm or a leg or whatever. There's a huge market, not probably locally, but overseas. Then aerial robotics. I can talk a lot about this area because I've been spending a lot of my time, especially these last 3 years, trying to design and build aerial robots. Drawn. So I can show you some of the videos to share what we have done already. So this is one of the first unmanned vehicles that we designed and built for 3 years ago. It's made out of a number of different materials, aluminium, foam, wood, etc. It was not designed using any software or anything, but we just use a standard model and scale it to the size. And it has a pusher propeller here. It's a battery driven. It has a battery, so it can fly about 20 minutes. And it has a real-time video feed, and also onboard high definition video can be recorded, and it has an autopilot. All right. So that was one of the first projects that we did few years ago. So this was the ground control station. At that time, you can see the real-time video feed and also all the flying stages of the vehicle over here. Airspeed, altitude, artificial horizon, then the direction, battery voltage, and the position on the Google Maps. And also the orientation of the plane. When it is far away from you, you can see it over here. But that is not actually real time. There's a slight delay over here. Um, so it is fully autonomous operation. You plan your mission, and it follows the mission all by itself, and then return home. This is the high definition that is not transmitted real time to the ground station, but when you have it back, you can take the video. So that was then. To play the whole video. Then I want to show you level to build a UAV, right, which can be sold in the open market, the global market. So we want to give it a nice and also attractive so that you get at least some market share, which is already been occupied by a few other manufacturers. So this is a high-speed one, different from Ravan, which is a slow, stable platform. This is not that stable, but can fly very fast. So you can cover huge area at the same time. And actually it was quite good, as you can see, flying qualities, right? Very satisfactory. You can easily put it into market. But when you want to manufacture it, not one unit, maybe number of units, you want to change your design and also manufacture, right? Not let's say, won't do that. And this will have all the capabilities, fully autonomous. Takeoff is manual, landing is again manual, but you can make it automated. In the next few months to come, we are going to convert it to fully autonomous flying, including taking off and landing. And we try to put it into global market. So we are trying hard to build this stuff. As you know, we don't have any high-tech products out of country to the foreign market. I'm sure you do a lot of things in software area, but not in area like this where you have multidisciplinary expertise putting into one single product. So we are hopeful that we will be able to do that. But in the meantime, I can show you something else. That is the aerial mapping uh, drone that we developed recently with the UNDP. If you want to get a map of an area which is on the border just for, say, urban development, you don't need a huge plane like heavy uh, stuff like Seahawk or Raven. You can use a relatively smaller one like this, for example, Flying Wing. It's about 4 kilograms, 4.2 to be exact. And then taking off can be done using a launcher. We recently built this just last week. Before that, um, uh, we used to hand throw it to the air with autopilot on, and it takes over from there. But when you put all the sensors and everything together, right, it becomes a bit too heavier to hand throw. But at the moment of taking off, if you give any roll error, the autopilot cannot correct it because it doesn't have enough airspeed to get the response from the. So therefore, we have to provide it at least about 10 meters per second airspeed initially. And then only the elevators around that response is actually significant. Otherwise, it's just like throwing a piece of wood into air, it just falls. So we got this launcher to work, and now you can see taking off is very easy. You can take off anywhere. You don't need a runaway, you don't need a vehicle, and you don't have problems with the hand throw. And also landing is a problem. Usually you need a bigger space for landing, right? And also before landing, you have to get the approach. You need to have a clear area to get the direction and everything properly adjusted. So therefore, you are talking about a huge open area, right? That's a requirement for landing for even small aircraft like this. But what we did was, because it's hard to find, right? You can't find it everywhere. So we designed a parachute, and we tested it. It was successful. So at any moment, all right, not only for landing, even for safety feature, you can eject it at any moment, and it just drop within plus or minus 20 meters from that point. Now, what is most important is this. Now, these UAVs can carry sensors like cameras, for example, right, and take photos every, say, 20, 30 meters. You can program it to take a photo. And you know the GPS location of each and every photo. You know the altitude using the barrel. You know the roll, pitch, yaw using the IMU sensor. And when you put all these information together, you can stitch the photographs together using their common features in adjacent frames. And then you can adjust it and create a big map, very high resolution. So this is one of them. This is our flying field. You can see our tent and our vehicles over here. And we place in one of these missions like screwdrivers the ground, and you can easily see them flying at 180 meters. If you can fly even lower, say 100 meters, you can see small things on the ground. So depending on the requirement, we can adjust the altitude, flying height, 100 meters or 180 or 300. During last flood situation, we flew at 300 meters. The map is created by Pix4D software. All in hand, when you have the expertise, right, putting everything together, designing and building by money, but we wanted to build it ourselves. Uh, the launches are already available. You can buy them if you have money, but we build it ourselves into our hand. So there's nothing seriously wrong with our parachute or our launcher. Uh, Even the autopilot boards we are designing, we get the open source code, whatever, more than happy to use. But we will change the code, like these planes, they're flying with some open source software, but we do the modifications, like when the plane is taking turns, climbing, and to land and all these things, we put our code into different places and test it. One single modification at a time. So over the years, you get very matured, versatile autopilot in your hand. That is how we are moving. The next thing I want to show you is uh, uh, I thought of starting this as a new area of research in my department. Opened a new laboratory for underwater robotics. You can see the electronics that goes into aerial vehicles, the system designs in aerial vehicles. You can see the same thing, about 60% common in underwater. So if you can fly, you should be able to dive as well. So therefore, it was easy to actually make this transition from aerial vehicles to underwater. So aerial vehicles took at least 3 years for us to get to some level of maturity, whereas this one took only 1 year. Just the labor, not any IP or any intellectual contribution went into this project. Just the time to put the mechanical design right and then the construction of it. So, and there were no problems at all in this 1 or 2 year period in the area of underwater. We call it unmanned underwater vehicle, but you can say underwater robots. So let me show you some of the videos of this. So this is the design that we did not copy it from anywhere, but we looked at the other design. But we want to make something of our own, some unique design. So students, they did it in SolidWorks with the two propellers on the left and right hand sides for steering and driving. And also another two over here and here for diving and flashlight over here to get some videos underwater, and tested it in one of the pools near Mr. Monitor. And we got the controls right, we tuned them properly so that you can drive it, you can steer it, climb it, right, dive without any problem. But we have all the other problems when you get underwater. You don't have don't have this slow bit rate links, so you have all sorts of problems that you find in underwater. So this is one of the final year projects 2 years ago, and then the last year we moved it into the next level. The receiver here floating on the water, and it is connected with the Cat5 cable to the robot. And just last year we improved it. So all of the robotic projects in Monaco in my department are implemented in final years. finally telepresence, they were all finally projects. But it's a big project, split into number of years. And the first part is done by one group, and then the second group, they are immediate juniors, take it to the next level, and so on. So after 3, 4, 5 years, we have a entirely done by, contributed by final year students. And we have the postgraduate program running in parallel. They come in weekends, and some are full timers, but they don't have time and sometimes I think expertise also to put things together and design and build things. Postgraduates time to think. They can make use of whatever things that the undergrads build, and they can put algorithms and test it on the planes or underwater robots, and they get results and write their paper. Combination between undergrads and postgrads. So we are trying that model, and it has been very successful so far. So what we did was we put another surface vehicle on water, right? And still they are tethered, connected. GPS video signals are transmitted from the surface vehicle to the ground control station, and there's a connection from here to here. Now the next year, we want to get rid of this tether as well. They will be completely physically isolated. To communicate between these two, we are going to use underwater link. It's very expensive, and hopefully we got some funding this year from the government, and it is one of the items we are going to go this out of that fund. So when we have that, we can do something really significant in underwater robotics, and we can design algorithms for communication and localization between these two vehicles. And then we can deploy this into actual applications like water quality measurements, search and underwater surveillance, and that kind of things. Okay, so probably that is the end of my talk today. So my purpose was to give you a cross section of what we are doing in Morocco. As I said to you, there are other academics in this area who are doing really nice good jobs in other areas, but I don't have the information to show. Even some of the academics in University of Morocco, like Dr. Harsha, is doing haptics, but I don't have this information to show you here. So this is how we are doing. As you can see, these are all really good work, but where is the money? Project out of generating money for the country, for the development. So that is a big question mark. I don't think even my work has generated any money yet. Research papers, reports, news, videos, they're all there. Where's the money? So I think we have to come to that threshold and try to convert one of these things to a product that can be used by our industries, or we can sell it to the global market. So until we get to that point, we cannot be really happy about what we are doing, even though the results are good. We haven't gone to that level. Whereas other countries, they have already gone through. So therefore, IEEE Robotics and Automation Society, I think our mandate, our objective should be a means to use this technology to design and build products that can be sold to in the foreign market, or at least to use this technology in our local industries to make the processes more efficient, make the product quality improve, or make the cost of production lower. So in whatever which way, if we can put this technology into practice, then we can be hopeful for a better future. Thank you very much.
would like to thank Professor Rohan Munasinghe for an extremely interesting and informative presentation. That was really an inspiring speech. We are grateful for the time and effort you took to share your thoughts and experiences with us. Now, I would like to introduce our second speaker, Engineer Nalin Karunasinghe. He was an inventor from his childhood. He has won a gold medal for Royal College when he was 13, and won a computer by making and capability computer from JICA. He was awarded as a junior inventor from IESL and was the youngest presidential award winner for inventing a telephone billing system. He was former Assistant Commissioner of Sri Lanka Inventors Commission, and he was awarded a fellowship from IFS for automating the superconductivity measurement system, and was chosen as a visiting scholar at Commonwealth Scientific and Industrial Research Organization. He designed email to pager, fax to email systems, and first VoIP gateway in Sri Lanka, and probably the first IoT product in Sri Lanka in 1997. He has done his postgraduate studies at National University of Singapore. He is the founder of eNet Solutions Private Limited, and electronic designing company for local and international markets. He developed Claymore bomb jammer and other products for Sri Lankan forces during the war times. He has designed the world's first plug-in hybrid three-wheeler. He was the team leader in the first IoT product designed, developed, and marketed in Sri Lanka, that is ePro 1000 by Sri Lanka Technologies. He is currently served as a senior lecturer at the Department of Computer Science Engineering, University of Monaco. Internet of Things, along with the basic demonstration. Now I would like to invite Engineer Nalin Karunasinghe to address the gathering.
Right, thanks for a nice introduction. Yeah, so basically, what I'm going to discuss is the Internet of Things in surrounding robotic world. Right? So, if you talk about like robotics, maybe according to the ISO standard, right? So called, and its beginning is in sort of 1937. Like what happened after they make robots? Like I mean. Earlier, like all the people were sort of doing all these manufacturing and production by hand, so it took longer time. So after these robots came into sort of manufacturing line, but there was sort of revolution, right? So it changed a lot of things in the world. Like I mean, people used to manufacture maybe thousands of cars in a year. Like we are normal, like people, if you could do it by hand, could do maybe 2 or 3 cars per month. So the production cost has come down and the world has changed. So like that, the start of internet, like maybe around like 1960s, and when it came to like about like 1993 or like 1995, like 2000, like lucky 1995, Sri Lanka got internet, and I was lucky to work for the pioneering internet company. So after the internet came into the picture, like the communication media and like how people communicate and like all the social interaction has been changed, right? So I think now you are meeting your friends through the Facebook rather than actually physical meeting them, right? So that's actually changed internet to the world. So it's called sort of Internet of Things. So now we have like 7.4 billion people, the population, and like when internet started, like they thought like it will be widespread. So actually there was sort of limitation on sort of IP numbering and stuff like that. So this now not only people, maybe even wristwatch or and maybe your toothbrush will be also connected to internet. So because this is sort of the expected growth in internet, maybe around around 2010. They had sort of more, I mean, internet connected products were more than the actual human population. So as a country, what we can think is because as Professor One said, we could contribute towards the economy, right? So one thing is now we are contributing a lot of things in sort of software field. Like the next thing is because when we have maybe 20 billion, 30 billion products, right? So we'll have controllers and stuff like that. So normally you call it embedded system. So when it comes to these embedded systems, so we need sort of engineers and sort of programmers. You know, I think more than 90% of you are programmers, but you are used to write programs for big systems. These devices will have some kilobytes. Like if you are sort of older like me, we used to have calculators, the memory of maybe just 16 kilobytes, and sort of hard disk of maybe 5 megabytes or even 2 megabytes, not the RAM, right? So now you have even cache memory of 2 megabytes in a chip. So that's a change. So I mean, sometimes we have to go back, because we are talking now in the IoT era, we are talking about very small devices, very low cost, low power chips. So these chips can't have a lot of horsepower. So when you write algorithms for things, you have to be very much concerned about the efficiency and how your program size will have to be changed. I'm not a hater of Java, but when I see Java, I feel I feel really embarrassed, right? So that maybe correct word, right? So I mean, so you will have to. I mean, if you really want to go into this, and as you know, I mean, maybe when I passed out from Morocco, in 1995, we didn't have a domain software industry like this, right? So maybe Y2K era has paved all the maybe electrical engineers, electronic engineers, all the engineers to the software, and it has created huge vacuum, right? So I presume maybe about another next year, maybe 2016, the graduates going becoming graduated who's going to doing A-levels these years will be should fill up this market. So they should learn the next generation should learn how to program these tiny devices. So, so I hope I mean I'm trying to give this message to all of you. I not also so they can move to this field because we can see a very big gap here, and basically I mean because we have to we can't miss the buses, right? I mean we miss sort of maybe internet bus or we are always missing this nanotechnology because we when it comes to sort of technology, I mean the time to market is a very the major thing to do, right? I mean, if you develop someone or if you came up with maybe CDMA protocol now, because it's already developed, right? So we always have to be a pioneer to get the sort of best out of the market, right? So if you start from now, I think we can catch the bus on IoT, right? So okay. So IoT. So what are the things we really need, right? So main thing is the definitely you need things, right? So things could be right? So another thing is like some sort of IoT toothbrush also, like I mean, to remind you, like if you forget to brush your teeth, it will send an SMS to your mom saying like your kids has not been brushed his teeth, right? So sometimes the kids will do it like they will play with the virtual marketing gimmick, right? And so because we may not really need it, but when all the world was going that, like we may have to have that, right? For example, I don't name anything like we don't want to go to that advanced, like because all our friends are using those word processors, we have to use it. So like that, right? And then we have to buy a big computer and we have to maybe another version of operating system to support that. Like sometimes the earlier version doesn't support the current version. Like so, these are some marketing trends and sort of marketing gimmicks done by sort of companies to sell their product, right? Said like. As engineers and some citizens, like I mean, we are doing research, of course, but always like unless we get think about the sort of economical side of it, I mean, we won't be able to find food to feed our kids, right? So we develop a lot of things and keep under the pillow, right? So yeah. So when it comes to things, so you have different type of things should be connected to the internet, right? So then you need some sort of input from all these things, right? So one could be like as maybe at least some of you are sort of interested in sort of robotics. So you have sort of pressure sensors, vibration sensors, maybe what you call load sensors, and tensiometers. All these are sort of inputs, right? And maybe humidity, and if you are sort of interested in sort of weather monitoring, the temperature, and maybe wind speed, rainfall, all these things are input sensors, right? So on the other hand, you should have some sort of so you have some servo motors, maybe artificial muscles, or like even simple LED output or simple buzzer is another ways of output, right? So you have if you talk a thing like you have some sort of input processing and you have some sort of output like same as sort of servo. And yes, then you should have a processor also, right? So when it comes to real thing like it's called industrial IoT. So mostly like people want sort of you may heard of this SCADA system that is uh, data acquisition and control of different machinery connected network, like that was sort of maybe the first IoT products available in the market, right? So because if you have sort of a very big factory, you want to measure like all the sensors and transducers, like maybe water flow or like even the temperature of your kilns and all these things. You can sort of monitor through the internet or as well as your maybe central control system. So this is sort of a high reliable and durable and dedicated system, right? But when it comes now, like as I told you, like I mean, we have to focus maybe 2015, 2020, 2030 era. And then we have to start from our younger generation, right? So there are a lot of things that even our kids can do. Like I mean, because like I mean, even my son, like he was when he was at grade 5, like he had the opportunity to like learn something called Arduino, right? So it's a very common platform amongst even school kids. So you can learn very easily because you know our time, like I mean, we didn't have access to information, right? So I mean, we have to go to the market and check the what are the ICs available in the market. Like we were dealing with the 741 series, right? So we have to check the what are the ICs available in the market, and we have to draw the circuit according to the ICs available in the market. Right? But nowadays, like you can just search the internet and you can get all the information, and you don't have to go as maybe see the domain where to get data sheet. You can just get all the thing in hand, right? Even if you have a data sheet, you don't have to read the whole data sheet. You should put the command like you show the keywords showing in the data sheet PDF file as well, right? Okay, so yeah, because I want to give you some sort of practical experience. So these are few open source products available even now, right? So you have these are basically Arduino platform, and these are maybe you have heard of these are Raspberry Pi, so you can put some Linux to that, and you can have different IO pins coming out of it, and you can do marvelous things. So it can sort of work. You can switch on and switch off LED to you can have high square bus, SPI bus, all these things coming out. And if you're sort of very much familiar with some Linux type operating system, you can use that as well. Like even these Windows 10 is also ported to this. So if you're sort of fan of Windows, still you can basically use this Raspberry Pi, right? So now thing is like, okay, right? Even my grade 5 kid is working with this, so I have to impress more, right? So luckily, like there's some other field which grade 5 kid can't touch it, like that's called FPGA, right? So nowadays, luckily, like maybe there are some FPGAs also available for like $10-20. Like these are FPGA chip developed by Xilinx. So if you want to do some maybe faster processing and don't want to compete with your son, so you can go for FPGA development, right? So yeah, so I'm back with this Arduino stuff, right? So so Arduino is like these are basically a robotic platform developed on top of Arduino. And very good thing is there's a lot of people contributing to the community. Like it's sort of basically open source community-based project. So there are a lot of libraries written for Arduino platform, and those libraries are very easy to handle, right? So but you can write in C-like code, right? Not Java. Right? So but these IDEs are written in Java. Right? Okay, so right, so yeah, so easily you can control all these microcontrollers. Like in nowadays, like I mean, when you want to write microcontrollers, maybe my final year, right? Maybe 19. I've taken my exam, right? Yeah, maybe 1995. Yeah, 1995. So we were maybe the first guys has access to microcontrollers, right? But we have to write the code in assembly language, right? So yeah, so nowadays, like you have all these graphical language also supporting this type of microcontrollers, and it's very easy to access, right? So yeah, so not only these type of boards, like I mean, there are sort of serious type of development kits like by Intel and these Qualcomm and Marvel, and especially like TI, which is not here, right? Also developed for these specifically for IoT type application. So the so this is about like devices. So you have different input sensors like accelerometers, like temperature sensors like that, and you have different output things. So you have some basic controller. Then we have to sort of do some sort of communication as well. Right? So when it comes to communication, also lucky or unlucky, like I mean, we have a lot of options, right? So one could be sort of ZigBee, Bluetooth, like 4G, 3G, 2G, and sort of 5G also now coming up, right? And these are low power Bluetooth, and you have Bluetooth. So all these protocols are there. So yeah, then the final stage is actually the computing system, because all these 23 billion devices running through the net, you have huge data coming through your network, right? So these networks, some information may be not very critical, right? For example, like getting temperature information every 1 second, like this is critical, like no. Maybe if you can get like if you miss 1 or 2 samples, like it doesn't care, right? So people are developing like because if it's not very critical, you can have transmission protocols, right? So people have developed that, and when it comes to like databases, like you may have to go for like NoSQL type databases, and you have to develop new protocols like because some devices are maybe not reliable. So I mean, suddenly it makes sense because we are talking about very low power devices, maybe spread over a lot of areas. So it may be sort of type devices also, like because it may be maybe radio. Sometimes it will be switch on, like it may be developing sort of ad hoc type networks. These will be running on ad hoc type networks. So because of that, like they have developed some sort of protocols. So one more popular open source thing is MQTT protocol. Like what they do is, so if I want to send a message, so I send a message to some sort of message broker, and it will keep that message until someone asks for it. Right? So that's the basic thing. So it has sort of three levels. Like I mean, one level is I can send only once and like that. So or otherwise, like if you want to sort of very reliable thing, then it basically asks from me the earliest data, like that. So even the data packets are missed, like depending on the sensitivity of the data what we need, we can basically program the level of uh, service quality. So this actually you can access sort of a gateway, and you can have sort of broker, and yeah, so the subscribers can sort of subscribe to topics. Like if I want to get some temperature information, then I'll subscribe saying I want to get temperature information of this store, for example, right? So there we will device transmitting all the temperature information and humidity information from this store, right? If something else, maybe air conditioner, I want to measure the humidity level also, like if you want to do some prediction of rain or activities, if you need humidity information, so it can be subscribed for that humidity information. Maybe lighting control for like lighting level like that. So that's what do by this MQTT protocol and things like that. Right? Okay, so the real thing is like we have sort of practical issues when it comes to real IoT, right? One thing is like security and privacy, right? For example, if you put my door lock is on whatever internet connected, maybe a thief can remotely access my door and give some sort of subcontract to another thief. Like I mean, there are different type of thieves. Like I mean, there are some thieves like maybe wearing ties and sort of have a high IQ, maybe yeah, sort of ethical guys working in front of the computer and do all the hacking, and there have been other thieves like who try to carry on pistols and all this stuff, right? And they can do some subcontract to another pistol and high-tech guy is like, yeah, that may be sort of clearly. Because if one device is transmitting like giving 1 minute temperature data, like I mean if you have 5 billion devices, like how much data you have to store, right? So you have to think about like data compression, data mining, all these things will also come in sort of one side of IoT problem. And when it comes sort of network, so you have to think about the range, right? So what the range you want to send it like, and sort of what will be some power requirements and reliability, and specifically the size, and of course the cost, right? So one of that, like I mean, you can have sort of different technologies, like I mean, you can have sort of last mile deliverables, and sort of from like maybe for a house you can have different maybe Wi-Fi or like Bluetooth or Zigbee type interface, RF, and within the next mile it could be like through as you know today, like ADSL or 4G or whatever. Right? So the other thing is like all these protocols are like developing very rapidly, right? So yesterday we had 2G, now we have like 3G and 4G. Like next year we are going to have 5G, right? Luckily, mobile phones really are changing every 6 months or so, right? It's not a very big deal, right? But what happens like if you want to replace your fridge every 6 months, right? And if you want to replace your car every 6 months, right? So it's not a doable thing, right? So luckily, like one advantage what we have now is like most of our devices, chips, and all these things are sort of based on flash ROMs, right? So like we had something called OTP, like it has diodes and you have to do the fuse on level. Right? So that can have to be thrown away if you want to change the program. But then there was thing, then there was sort of window-like thing with UV-like, you can basically create and do it. But luckily with these flash ROM, even you can download the firmware remotely, right? So that's a very good thing. So if you have any protocol or something to run on that, you can basically flash and basically you can upgrade, right? So nowadays you have mobile phones come up with very buggy firmware, right? From the factory, right? But when it comes to you, you have very handy and whatever the centimeters and all these gates and all these things, right? So you can basically upgrade when the end users level, right? So that's the advantage of having these flash ROM based systems. So so we can get use of these to solve some of the problems, right? But other problem is there are nasty guys, right? So there are guys like yes, after that, I mean, there could be like one A company like maybe LG, maybe Sony, maybe Mitsubishi. All these companies will be developing maybe televisions, radio cassettes, and all this stuff, right? And maybe some other people will be developing these garage door openers. What else you want to control? Maybe burglar security systems and all this stuff. So these things will be done by different protocols and different technologies, right? Okay, so solution for this, like I mean, you want to replace all your household districts by Sony or Philips or lighting system, all this will be issue, right? So one solution for this will be something like IoT gateway, I think. So it will be acting as sort of gateway, and it will be communicating through maybe some sort of substandard protocols like Wi-Fi, Ethernet, 3G or 4G, and all other devices. We still have sort of multiple access to your energy meter, smoke detector, light sensor, and all these things. And this will be working like multi-protocol level. Like we still have sort of access to ZigBee, maybe on-off being just plain RF, or like 485, whatever the things that you need. So this will be a sort of one solution that comes, right? So we have sort of problems and we have solutions, right? So as an engineer or like as a solution provider, we should try to identify the problem. We should try to sort of solve it, right? So that's the sort of way we should go, right? Okay, so when it comes to this sort of this scenario, like I mean, maybe maybe at least 50% of you come to this place by your own transport, right? So using private transport, what's the major problem? I think more than traffic, the parking is the major problem, right? So yeah. So one good thing is like this proposed system, like I mean, before you coming, like you can find the parking place, right? For example, because the security guy told me like it's better you can, I mean, because he wanted to send me out of that place, so he asked me to, sir, the lecture hall is further down, maybe you can park there, you may have space, right? But I don't want to take the risk, so there was a empty space, so I parked there, right? But if I said that it's free for me, then I should have definitely come here and park. Then the other issue is like, okay, I have that information, but how can I be sure of it, right? So there should be some sort of parking booking system also. All these things can be come into picture, right? When everything is, because you are going to pay for that slot, right? So then that slot will be reserved for you. All the ladies wearing these blue color gowns and all, like collecting money from you, will be parked in the CMC areas. So they can in charge of like getting all these three guys particular place, right? So this is a one good scenario. Like even nowadays, you can use some of the IoT thing for like parking. Like then before you particularly go there, you know like how much. I mean, whether the parking slot is available and things like that. And even government can make real money out of this. Like government can charge, I mean, maybe even 100 rupees for parking. Right, because people will be bid for this, like, and we can have online bidding system for parking also, right? And so these are things like even the government can sort of make revenue out of it, right? So government or like even I do the management of these buildings, I because they are going to do this. Right? So you have to pay more parking fees. Right, anyway, right? Okay, so there are some few practical solutions, right? So one thing is which you can see here, right? You can see, actually I have to take a photograph of the ground, right? So you can see a small IC here, like it's called ESP8266 IC, right? So the advantage of this is this has a Wi-Fi protocol, and it has a microcontroller also. So it has all different, right? So these are board which is this particular IC, right? So these are board which is have different peripherals, right? So this is a buzzer and LED, and this is a simple relay like thing, and this is sort of when you turn this, you can get sort of multi-current potentiometer, right? And you have basic switches and things like that, where you can basically experiment quickly, right? The good thing in this is, as I told you, this Arduino platform is very easy to use. They have basically ported Arduino to this one, right? So if you know how to program Arduino, you can program this chip, and this chip cost, can anyone estimate how many dollars? Yeah, it's less than $150, right? So less than, right? So this is the cost of the technology, right? But the reliability and other things will vary. But if you just want to switch on and switch off a light, I mean even the normal light switch will cost more than 200 rupees, right? So you don't need wiring, and maybe there's a sort of market entry point at this place, right? So and yeah, so these are sort of simple application given by some of my colleagues, right? So Madhukar, Dilip, and Madhuk, right? So I mean they have developed this application within less than 1 day, right? I mean maybe for like half a day. Right? So which I want to tell you, it's very simple. Like I mean, I told you about like industrial level applications. Right, so these are very simple web application, right? So here you can see the chart, right? So because this is the time we came inside the air conditioner room, so you can see clearly the humidity drop, right? You know the humidity also dropped inside. So that's one thing, cool, right? And the other one is the sort of temperature. So this temperature also dropped to 24, right? So right, as well as it has sort of relay, so you can turn on the relay, right? And I can just buzzer on it because I put a sort of about like 9-second delay, right? So you can hear the buzzer, and you can hear the sort of bus, and you may hear the switch on of the relay, right? So if you can connect, simply connect just the bulb to that, then you can switch on and switch off bulb, right? So here you may have seen there's a blue color LED. There's sort of let's say RGB LED. So I can click on this, and so I can change the color of that LED to that particular point which is switched, right? So these are sort of some things you can do with this $1 electric chip with Wi-Fi technology, right? So good thing is like if we try to sort of play with this type of stuff, then we learn how to sort of go in sort of next level, right? And right. So yeah, so these are another product actually we developed in Sri Lanka. So maybe on my introduction I told like design, develop, and market, right? So although I said like we made like maybe first IoT product in 1995, which we were not marketing it, right? So as Professor said, like I mean, unless you market it, then there will be no impact, right? So this is a product we market. We have designed this for Sri Lanka technology. Like some of it, so you can master business on them also, right? So we have made this not just as a sort of a power monitoring device. We have made this as a sort of IoT gateway hub, right? So you can see it will support these IR, Wi-Fi, and PLC, Bluetooth, Ethernet, and Zigbee, all and RS 485.232 protocols. So if you are on and this on-off keying also. So if like most of the home security system is working on on-off keying technique. So all these things can be sort of interface this, and according to the protocol they use, like we can sort of upgrade the firmware, and this can act as sort of a gateway hub, right? So that is the basic advantage, right? And after that, then it will send to the cloud using ADSL, Wi-Fi, or sort of GPRS technology. Then it can be shown on your tab or mobile phone or whatever the device, right? So it can, so it, as a sort of power device, it can measure all these power monitoring power factors, and if you sort of for control the main breakers and stuff like that, and real-time production cost estimation, and you don't have to wait until you get the real, right? So yeah, so these are products which came with the smart home thing. Also, like these are one product we have developed and marketing in Sri Lanka. So maybe our marketing team can go to like foreign markets also, right? Okay, right. So thank you, and yeah, so we are going to have this demonstration maybe next table after the discussion and everything. So you can basically ask questions. And other thing I want to tell you is like because if you are sort of maybe at least 20% of here, I think familiar with this Arduino platform, right? So yeah, so if you are familiar with Arduino platform, right? As a sort of fresh thing, you basically have to install Arduino, but to use this chip, you have to download specific code from this GIT hub, and you have to consider this by doing these references, and you have to put the board manager plugin, right? So you have to do this to program this using Arduino, right? So can you have some raise your hands who have used Arduino development kit earlier? Okay, at least I have. Okay, I have about 50%, right? So have you heard of this ESP8266? How many of you have heard of it? Okay. Have you known that this can be programmed using this Arduino, this thing? Right, good. So at least I think I have saved, I mean, some of the time of at least 20% of the people. So they'll be happy to learn this activity, right? So yeah, so I think I have done my job, right? So right, thank you very much. Maybe we have some discussion. So after that, you can ask my colleagues and others about how to do this. And people are not very much familiar with Arduino, so they can start using Arduino because it's sort of a very good platform to start with, right? And I want to ask question and you donate. I mean, want to give prize, right? Is there anyone less than maybe 20 years old here? Okay, so you can answer my question now. Yeah, tell me 3 RF communication protocols. 2 RF. Okay, is there anyone less than 25 years? You can answer. Less than 20 years. Less than 20. Less than 25 years, who can answer the question? 3 RF communication protocols.
NFC, RFID, Wi-Fi.
How old are you?
20.
Yeah, I can do that.
I would like to thank Engineer Lanka Singh for your nice demonstration, along with this wonderful presentation. Now it's time to start our panel discussion. We have analysts, and they are Professor Rohan Singh, Engineer Lanka Singh, and I would like to introduce Mr. Anuradha Veeraman, who is the Associate Director of Mobile Solutions and Digital Practice at Polaris, and he is currently the Principal Architect of Mobility Practice at Polaris in Colombo. He has worked for a large US-based ISPs architecting complex JWE, Unix, mainframe mobile, consulting, and strategy. And then I would like to introduce Mr. Heshan Pereira, who is the Technical Project Manager at Zone 24/7 Private Limited. Experience in working with Tier 1 retail and US to design and develop domain-specific ground robots. His primary focus has been working closely with electronics, mechanical, embedded, and software engineering teams to collaboratively develop perfect ecosystem, painless deployment, and extending the utility of robots to retail. And our panel moderator is Dr. Sanat Javardhana, who was graduated from University of Moratuwa in Electronics and Electronics. He obtained a Master in Operational Research from the University of Moratuwa. Dr. Javardhana has obtained his PhD from Saga University in Japan, Robotics and System Control. In addition, he was awarded by Professor T.T.F. Silva Award for the Best Overall Student in Masters and Best Paper Award from Society of Instrumentation and Control Engineering Kyushu branch. He published many international and international journals. He is a chartered engineer and the chairman of IEEE Sri Lankan section in 2016. And prior to that, IEEE Sri Lankan section. Now, I would like Abdana to moderate the panel discussion.
Good evening, everybody. This is the Robotics Meetup, and robotics is the branch of technology that deals with design, construction, operation, and application of robots. So we would like to touch all the aspects in the discussion. This is yet another event organized by IEEE Robotics and Automation Society, Sri Lanka section, in partnership with IEEE Sri Lanka. Discussion is planned in this way. It is going in 3 rounds. First round, we will get to know about the panelists. Then in the second round, we will focus on role of robotics and its development in diversity. Third round is dedicated for you, and you can ask any questions from the panelists. And finally, we would like to conclude it with conclusion remarks. First, let me to introduce the panelists. Professor Rohan Munsinha, Professor and Head of Department of Telecommunication Engineering, University of Morocco. Mr. Naveen Parmasinha, Senior Lecturer, Department of Computer Science and Engineering. Mr. Keshan Pereira, Technical Project Manager at SON 24/7. And Mr. Anwar Veeraman, Associate Director of Mobile Solutions and Digital Practice at the Virtues of Collapse. In the first round, I would like to ask from Professor Rohan to start the discussion. You were identified as an academic who intensively involved in academic research in robotics, especially in UAV and water robotics. I'm sure that audience would like to know how you become more pioneer in robotics in research.
Let me stand up and talk about this. You can't see me, right? How I came to the field and how I became a pioneer. You call me a pioneer. In fact, I converted my applicable to all of us. If you are doing a job which is not in your interest, you cannot be a pioneer. You cannot be a leading figure in that area. So I was lucky to make that happen to me. So I want to build things, control things, optimize things, all is wrong. So I will continue my career the same line for the rest of my life. And I also don't want to stay on one single track. When I come up with something, I want to use it as much as possible. Not only to solve the first and foremost problem, but to use it as a solution to the other problems. I then start seeking problems for which this can be a solution. So that is how I converted my UAV things into underwater. And there you can actually make good results in free time. Then that is what I am. So the other part of the question is in education, especially undergraduate and postgraduate education and research, academic and research work, all work. When I came back 2006, I came up with a lot of hope and resources and got a lot of stuff to start robotics. I knew that there's no course in robotics, so I started off in the first course in robotics to the undergrads. Anybody in here graduated 2006. They had a chance to enroll to robotics course. So I started teaching robotics, but I teach it a little bit higher than I should have done, so that probably the first batch will get good results. And I then cut down the syllabus, shape it up so that students learn it with some interest. So I added practicals and a lot of vibrant stuff into the module. Now much more hands-on. Now I've got a robot also into my lab. Not only automatic. You have to change that. Oh, you can hear me, right? Yeah. So when you are the first in any area, you become pioneer naturally. So I became a pioneer in robotics by nature because there was nobody else to do that. Initially, that was the thing. Then I started robot competition, the small autonomous robots that you saw here in my presentation. That was a very tough course for the undergrads. I knew it. That offered at MIT US, 6,000 category. The students, they have to design and build a robot other than going into lectures, going into labs, presenting their proposal to a panel, including myself, and showing us how to be a winner at the end. It's a very tough course, and they only get 2.5 credits out of that. But it was the most popular course in the higher BSc undergraduate program. So because I think students liked it, they wanted to put hands on the things. So I realized that the potential is there. That is how that course decorated the whole undergraduate program. Then I quickly started the new areas. As I said to you, I don't want to stay in one single thing. So when the robot competition is going on, I left it to my juniors and instructors, right? And then I started an unmanned aerial vehicle thing because that was the future at that time. Now we see how drones are used for various applications. So you saw the 3D map, high resolution map here. So we are on par with anybody else in the world because we started earlier. So we need to look at what's going to take 5 years and start it today. Then only you can actually in par with the others. So we can compete at least in one of these areas, robotics, with the rest of the world, I'm sure. So that is how one can be a pioneer in one area. You need to focus on one line. You cannot look around, right? Then you are not moving forward. But in the meantime, within that area, you're looking in a solid angle. It cannot be 1 or 2 degrees. So it has to be maybe 5-10 degrees. You switch back and forth, but you do not lose your focus. So then you can become a pioneer. So that's what it is.
Thank you very much. Next, I talk with Mr. Nalin Karma Singh. You have started your career as an electronic engineer in 1995. Then your nickname was Professor in final year, as I know, right? Then you are a very resourceful person to the university student by that time also. That's why your nickname. You deserve for that, actually. Then your later your name is in the history as the first IoT inventor in Sri Lanka. What made you an inventor? Is there a secret behind it? Can you share that secret?
Yeah, actually, to tell you frankly, like I didn't start my engineering career, right? Because as a kid, also like I was fascinated by the engineering things. Like maybe about like maybe 90% of the kids, like if you go like if you see like even forklift or like even train, like kids are so interested by of looking at, right? So I think that's a sort of first start of being an engineer. Like to sort of admire how things work and things like that. Right? Because I think I was fortunate. My parents were not forcing me to do only book studies, right? So they allowed me to do all these other crazy things, right? So I was not very much focusing on marking, but I was managing engineering and everything. Right? So then sort of I was one thing is like I was used to like see problems as Professor said, like because you want to see the problems in the society, right? And then with your knowledge or like then you can sort of basically try to solve them, right? Then you don't have to. Then other thing is you have to think out of the box, right? I mean, frame it to one thing, then you won't be see outside. So that's why I told like I has not time because 1995, right? So because when graduation process, sometimes you kill your creativity, right? Because when you don't know anything, you are sort of free to do anything. Like because I may have I can't remember now, but I may have tried things which is impossible to do practically, right? But I didn't know that. But I was just trying, right? Because I didn't know that it cannot be done. But there we think about sort of the scientific history. Most of the sort of remarkable things like discovered by not doing the correct way, right? For example, these radio physics, right? So okay. So the guy has asked to do some measurements. So instead of that, he's sort of facing astronomy. So he has focused telescopes towards the star, right? So that's sort of start of, right? So these are some things, right? So so one thing which I want to tell you is like I have become inventor by trying to solve problems, right? So one thing is like, because at that time computers are so expensive, right? So maybe about like 6,000 because our parents' salary was less than 6,000, right? So they afford a computer, right? I'm talking about business spectrum computer, right? So I was really fascinated about these computers also, like, but we needed money to buy, like, no one was able, I mean, no, not a middle class parents could have bought it to kids, right? So because there was sort of another competitions and things like that. So then we had sort of MCQ papers, like, so I saw like my teacher was marking these MCQ papers by keeping another mask on top of that pen sort of marking it, right? So at that time I was LDRs and lights and all these stuff. So what I've done is like I thought like if I sort of basically scan it and then I can have sort of set of LDR and basically I can have sort of a simple counter like UI and I can make a thing, right? So at that time I didn't know that there are some counters, OLSC sizes, right? So the good thing is like then I didn't know how to do it. Like then at the back stage of Vesak Pandola, I saw like Quran protocol. So these things like I saw like how it works, right? So I was applying that technology with that. So that's I know like and if you learn like something like this, that will be not very much interesting, right? Maybe. So I was managed to be, so there was problem like because when you have that, you have these sparks, right? So if you have sort of multiple sparks, wow, then your count will go like students will get like more than 100% marks for the NC, right? So I was trying to solve that, like then that was sort of worst part of my this thing. Then I was trying various things like I was trying to put sort of resistors. I didn't know about electronics, so that thing like that sharpens my mind. If you learn something, then I may have just used just LCR circuit, right? But learning it hard way like gave me more sort of avenues to learn further, right? So nowadays also like sometimes I don't see the sort of clear path, like I see sort of alternate path like where you can solve it by other means. Like there may be sort of standard way to do it, but alternate way may be more efficient, right? So if you come up with a sort of more efficient way of solving problems, like it could be a sort of very big thing, right? So example like my these hybrid three-wheelers. So I have done some experiments, so I don't want to disclose the technology. That was a very, very simple technology. And even I went to sort of meet some of Indian three-wheel manufacturers, they couldn't figure it out. Like that basically because they are thinking on sort of traditional process. Like if you want to be inventor, always one thing is you should try to solve the problem. And other thing is you should always think out of the box, right? So that's the advice I have to give, right? And other thing is you have to have passion on the work you want to do, right? Then you can definitely succeed, right? If you don't have passion on that, forget do another job, right? So that's why my advice to all my colleagues and like people working with me also, right? Okay, right. Thank you. Yeah,
Mr. Keshan, your initial specialization in software engineering. Later, your focus has been changed and you touched the robotics field. Then, your journey.
Right. So, as Dr. Sanath mentioned, my origins are from software, and they're still predominantly in software. So, where I work in Zone 24/7, we refer to ourselves as a technology solutions company for a reason. We are not purely software, we are not purely hardware. We work with both in order to come up with full-fledged solutions. So what happened was, as soon as university joined the industry, I ended up working with in a domain where we were at the edge of software and hardware, where we had solutions. And I was a part of multiple endeavors of Zone 24/7, where we developed and designed and developed hardware and the software in order to make it useful. And this sort of made me an obvious choice of one of the next biggest problems that we were going to solve in US retail. The problem that we were asked to solve is, you know that these brick and mortar large retail stores are really getting hit by online retail markets such as Amazon. And one of the major hit points for them is the efficiency of inventory management. So our goal was to come up with an economic mechanism of giving item level visibility. For example, if you want to know exactly where a pair of Levi's jeans is in a particular store, it would give you XYZ coordinates of where to go find it. It would tell you exactly this number of items are there. The original problem given to us. And so, okay, I'm from a software background. But what happened was, to solve this problem, we had to work together with our electronics department, with our embedded systems departments. We had to work with our mechanical engineering. And it went through a very interesting evolution. So we started off with exploring areas like static RFID readers. Then we went on to, basically, because of economic reasons, we went on to exploring the idea of drones. Then due to the aspects of danger involved in, so what happens if a drone in India fails, it can cause a lot of damage. Due to those, we resorted to, okay, we need to develop a ground robot. And from there onwards, we have been, so see, we've been talking about how do you make money out of robots. Major area that we may be overlooking is the aspect of all the software that is required to make these robots useful and appealing to the world. So the thing is, this software, when you think about it, you can't really work isolated. The teams can't work isolated. So what we have been doing is we've been working with our mechanical engineers, our electronics engineers. We have people specifically solving problems such as simultaneous localization and mapping. We have people working purely on our depth sensors, people working on bumper sensors, people working on odometry, autonomous docking and things like that. And how do you bring all of these into a useful sense that is deeper into a real environment? How do you take it beyond an R&D stage to an actual production environment? So this is the exposure that I've got in robotics. I'm not someone who has been working in the nitty-gritties of how do you solve a really good a SLAM or simultaneous localization and mapping problem in a specific domain. I'm not someone who has been working purely solving an index, but working with all these people together to make sure that we solve this problem in a manner where we work collaboratively and end up with a product that we can actually sell to the market. And that has been my field of area of work.
You are a technologist with over 12 years of experience. Later, you become a weak robotic enthusiast. Can you share your life experience in robotics? Can you have some experience from robotics?
So I was a software consulting and IT services company. So here my background is in software, and has been so for a large part of my my career. But in the last year or so, we actually got a very interesting project at Robotics, which was a pioneering project for us, our very first IoT project, long after we also. So, and in that, during that project, what we did was we're solving a very complex but very common problem in terms of medication adherence, and it was for a very large US-based healthcare services provider. And we built a smart device, a smart hub, completely industrial design, designed for manufacture, polished, and it was received very well. And during that process, we learned a lot. Actually, I learned a great deal about how the hardware meets software, and how we can design products that people want to buy or people want to use and love. So that was a great revelation for me and a great learning experience. And post that, I'm involved and interested in robotics, and I do not have a robotics background, unlike this elite panel here. So it's mostly self-learning, and taught myself everything I know. And as part of that, I was very much involved in, interested in swarm robotics, especially, and built a small swarm platform with which I can conduct my own experiments, sacrifice a number of late nights and weekends in order to get that. But as part of that, I learned a great deal and really found out how open hardware can really be used. And can be used by folks who really want to learn about this technology. So that's probably something I'd like to maybe talk to you also, and see how I can benefit some of the folks who are at least trying to get in this, right? And not benefit from it.
Thank you. In the second round, as a starting point, Professor Rohan, can you then, with the advent of technology, robotics has developed in diversified fields. Can you classify what type of robots development and the challenge encountered in the history of development?
Robot classification is very diverse, very diverse. You can find robots almost anywhere. Not like 50 years ago, there are robots could be seen only in industrial plants, manufacturing plants, handling parts coming out of foundries and mating them together and things like that. Now robots have come to our doorsteps, and they are in every field. They are in hotels, they are in hospitals, post offices, in houses, filling stations, hospitals everywhere, even in operating theaters. But we need a classification, otherwise we cannot have the structure and we cannot streamline. And we cannot figure out what are the major core problems that will stem out as a different field. But it is actually industrial manipulators. This is where, as I said earlier, is generated. So if you look at the development of the countries, if you line them up, the developed world, right? And also you can figure out the usage of industrial robots. Forget about all the other types of robots. Forget about drones, underwater, industrial robot manipulators. Then you can see very strong correlation with the development of the country and the usage of robots. Examples, like what is the country in the world with the highest robot density? Japan. And we know what Japan is. It's not US. US is huge, the biggest of about the highest density area of robotics. But epicenter of robotics, where most of this innovation is happening. Where is it?
US. They use the planetary robots.
Yeah, but it's not still the epicenter of robotics innovation. It's in Europe, Germany, France, some parts of UK. It's actually, you cannot pinpoint, it's Europe. And US is the biggest user of robotics. So that is, they are whole world. There is a lot of money by using this technology. What are the other areas? Other areas, okay. If you think of mobile robots, they have not been in the markets, any of these markets, up until very recently. Now it's the time, like Zone 24 by 7. They're trying to put a ground robot with all the sensors, this kind of inventory robot. So now it is time for mobile robotics to find out their identity in the industries. But I think it has not happened to a very significant level because of the problems. I think Shehan pointed out this land problem is there. That is why mobile robots can be deployed easily in the environment, because the environment is very chaotic, unstructured, there are moving obstacles. These problems are really tough problems for an autonomous mobile robot. So how to solve this problem? You need to have AI developed. I papers about 5-10 years ago, and they say the experts in AI, they say AI is not that intelligent after all. So what you see as intelligence is actually brute force searching happening in the back end of the system using very high speed hardware with huge memories. So if you have all the information of the world, you don't have to be intelligent. You know your solution is there. You just have to search it. Even searching doesn't have to be very optimized. You can have a brute force search because hardware is so fast and the storage is so big, you can always get to the solution. Whether you're smart or not, you can get there. So therefore, AI today is something like that. So somebody has to now make a breakthrough. So make AI intelligence. If somebody can code it, if somebody can find it out, then it will be a huge revolution in robotics and also in robotics related industry. So one of the major problems in robotics is AI. And the other one is obviously vision. Without vision, robotics cannot go into the next level. Vision is kind of the ultimate sensor. It has a lot of information. You can think about other sensors, but none of these sensors come even closer to vision. So vision is a problem. So if you use it for face recognition, And if the person comes with a beard, without a beard, for the system it's 2 people. And if you have different life conditions, again, it has become very fragile yet. So future, the near future, hopefully, these problems will be solved. And if you get the vision and also AI into the next level, you can see a booming revolution in robotics. And you can see a lot of robots, mobile robots, everywhere, with a lot of solving a lot of applications. So the two problems, remember, is vision and AI. And the other categories are obviously, as you know, the autonomous vehicles. Again, they are mobile robots, basically the same problem. But if you look at the Google car, it has all the information of the world. They are putting the entire world into a small chip. So, you know, every road, whatever country, right, you know everything, you know, what are buildings around where the trees are. So if you have all the information, you can drive it. Right? And the ultimate target is to do it that way. Again, because of the other problems. AI has not developed that. You can't have dynamic response to the situation. So you have everything already in place. You know whole world, and whole world is in your palm. So you just take the information and take the decision without thinking too much. So that is how the world is going right now. The other thing, other area in robotics, other category is biomedical engineering. That area you have heard of endoscopy, laparoscopy, surgical robots, and BTC, surgical robot system, where you can undergo a surgery without actually opening your body, and tools inserted into the body and do the operation inside, and after that you get tools out. What is left in your body is just small three or four incisions. Okay, so now there's a lot of surgeries happening in Sri Lanka in this mode. We call it minimum invasive. So this is another area. Then the rehabilitation and prosthetic arms. Again, we get into biomedical. That area is a huge funding for that, because the whole world is engaging. You know that if you look at the percentage of people above 60 years of age, it is increasing. We will take care of our elderly parents, right? We have felt that. Now this problem will become even more worse in the future. So the solution will lie in this area of robotics. So we will have to design and build robotic systems with enough capability, intelligence to look after elderly and disabled people. Therefore, these operators are being developed. So these are roughly the categories of the field of robotics.
Mr. Nani, you briefly describe Internet of Things, how it is in your speech, how it is using do-it-yourself environment. Then it is not only limited to DIY environment, but also to distributed control system as well as optimized electrical energy usage or consumption. Then can you elaborate on that?
Yes, yeah, actually, first I want to elaborate on like DIY level of most of us here are sort of young, are sort of doing these IoT and robotics as sort of hobby, as not as sort of your major work, right? So to help them, so let's say as we have like IEEE organization also like we are sort of planning to have a sort of hands-on session like on this IoT development platform, like and what are things we can do and things like that. So probably one thing I want to do is a small announcement also, like I'm taking this time. So if you can sort of we can have some paper. So if you can write the name and the telephone number. So we have not taken that plan when to have that particular workshop. So we can basically contact you when we have that, right? So one thing is you can basically fill that form. and we are going to discuss about like basic IoT technologies, like how to build a sort of simple IoT enabled hardware, and what type of like protocol we can use to communicate, and on the back end, like what will be the sort of back end communication server what we are going to use, and sort of maybe you can develop a small Android app, or like you can check on the website, right? So that is one thing you can do as a sort of DIY thing, right? And the other thing is like because we want to promote, as I told, like, and maybe Professor Rohan also like mentioned this about like because we have to sort of come as sort of right. So we have seen like during the industrial revolution, like all the countries which had sort of access to this robot technology has become leaders in finance, right? Financial as well, right? So other countries like the European countries, European countries and stuff like that. So like that, later like we have seen like because like software industry is also booming, like countries like India and Sri Lanka, even Sri Lanka, like we have become hub on like quality software developers. Right? So either like from different sources, like I mean, our software is considered like much more high quality software to like our neighbor India, right? Although they are delivering more, and their total income of software is much higher than that. The quality wise, I think we are leading. Right? So like that, I think because this maybe for like another 5 or 6 years time, the next thing will be sort of IoT based devices and things like that. Right? For that, as I told you, like development will be different because we have two software, two sort of low power embedded devices. So then that's one reason we want to sort of spread that in sort of younger community. So when they become sort of engineers or like software developers, then they have come up with a sort of passion, right? As we all said, like we should have a sort of passion to uh, the work we do, right? So I think if you take most of the successful people in the world, like they have not done their job because they want to do a job, right? Because they have started these companies and they have they had sort of passion to do that, right? So like I mean, if you are given sort of intensity to do your hobby, right, you'll be willing to do that, right? I mean, you won't feel that. You won't feel sleepy, right? I mean, maybe day and night you work and then you can come up with some desire. So that's one thing we want to sort of promote these IoT technology. I think another thing is industry sort of backing, right? So when it comes to as I told you, like satellite things, right? Or even these power monitoring and things like that, right? I mean, because nowadays, like like energy is the most precise thing, right? I mean, if you don't have energy, like that will be really dying for that, right? And these pricing are going up, and we should know about like how to basically manage energy, right? So we have basically started working on this energy field at Sri Lanka, like, and we were sort of starting to do sort of basic because we need because IoT comes up with sort of big data, right? So to analyze things, we need a lot of data, right? For example, like if, us, right? Sort of if you do some sort of medical test, right? So what they do is like we basically measure our sugar level, maybe we measure our ECG and things like that, right? So like that, if you take the industry, like industry also has sort of machine, and it will be connected to sort of power sources, and these different machines will current, right? So I mean, even the loads and stuff like that. So if there's a load pattern, then we can tell the health of this particular machine, right? So if we have sort of big database of that, then we can basically tell before something goes wrong, right? I mean, if you take sort of manufacturing industry, if we can sort of detect it before the failure happens, that's why that will be preventive maintenance, right? So we can prevent the failure, right? Not good and things like that. Then we current will have some spare. Like they have actually measured the sort of power consumption in the air conditions, and they have able to reduce, I mean, increase the temperature of the air conditioner by about like degrees, right? So then you can save a lot of energy, right? Sometimes the air conditioner can be increase the temperature, but you can and your cycle time can be sort of another chilling factor, right? So these are some areas you can study in some energy, and then you, if you have sort of distributed networks using IoT technology, then you can gather all the information which is required, right? And for example, these type of sensors, you can fix, and each case you can basically monitor the humidity and temperature levels, right? So then you can basically have some idea like take some idea like comfort zone, right? Because mostly our comfort zone depends on the temperature and the humidity level, right? So if you can maintain sort of sustainable temperature as well as a little bit lower humidity, then our comfort levels can be increased. So by that way, you can dynamically adjust your air condition. Rather than like, for example, here like I'm just sitting under aircon, the temperature here is very low, right? But in some places, there will be very big variation inside the room, right? Because we can think about these ventilation things and other factors dynamically, and be a practical solution, because these are sort of we have access to cost-effective solutions, right? So we can install maybe few hundred sensors in one building, right? And it doesn't consume much of the bandwidth, right? So by that way, you can properly study about the field, right? So everything is becoming smart. So we call it smart building, right? I mean, then you can talk about like smart cars, as Prof said, like because car is smart because it can drive itself, right? So you talk about like smart robots, right? Because it's smart because it can find out where the roads are, where it should be hanging, like if you and different ways, you can sort of renegotiate and put together. So these partners, IoT, all these things sort of intelligent robots, everything comes in sort of one is connected with each other, right? So one is basically access and information, I mean access to the information, right? So that's the first thing. So if you have all these things connected properly, and if you have some AI to analyze those things, the big data problem, then progress, all the product enhancement is achieved.
Thank you very much. You have enlightened some application of IT. Mr. Kishan, you are interested in ecosystems. In the ecosystems, pain like extending the utility of robots to retail. What is mean by retail?
Right. So, especially a country like us trying to deploy or trying to reach a robot competing with so many German robots, US robots out there, need to bring in something more into the table. Now, okay, we've developed a robot that can perform, it can go around the store autonomously, can navigate itself, it can perform RFID scanning, capture that data. The next thing is, there are so many other problems that come along when you actually, it's not like sending off is going to be hung somewhere. Maybe, is anyone familiar with the term kiosk? Right, so it's not like having a stationary kiosk somewhere. Now, let's take a few examples. One example is, when these robots are deployed, how painless is it for them to maintain it and basically have it running? So, see, when we retail stores, we are talking of thousands of stores. And when you have such a geographic dispersion or geographically separated deployment of these are things like cars, right? When they break down, when we have to continuously monitor them. What's wrong? It should be remotely fixable. These are moving; they will have a lifetime. So, how do we streamline our processors so that we can replace parts in time, minimizing downtime. Then we need to think of also when it comes to troubleshooting. These people, now if we take a lot of this machinery, let's take industrial machinery, generally the people working on them are tech side, but the domain they care, these are people in very layman terms who are not even that qualified. So how do you expect one of them to be able to maintain or even let's say perform a very rudimentary troubleshooting of the robot? Would you expect them to go unscrew something and then go check if a wire is connected or not? Right? So we need to have solutions in place which enable, it's like something for dummies. So we need to have sort of a dummy guide in order to in such a friendly way. We need to have mechanisms such that to open it up if they have to, taxi it away. Say for example, the robot breaks down or runs out of power and is unable to return to its base station in order to start charging. What do we do in those situations? Is it going to be grounded somewhere? How does someone come and take it back to its original location? So each of these areas where we need to think about when we are talking about deploying a robot to make it painless. So it's not just about purely focusing at the problem at hand, which is getting it first and then somewhere. It's about making it very easy to use. It's sort of like will you use a mobile application that is difficult for you to use if you can do something with a single click versus an application where you would have to go through 3 or 4 different clicks to do the same thing. Which one would you select? That we're trying to create through our robots, from the mechanical design software and to the basically. So that's one thing, and creating an ecosystem for extension. It's very interesting. So this, have you heard of this quote by Steve? People don't know what they want until you show it to them. The same thing happened to us with robots. Initially, our problem was in terms of solving an inventory problem. We wanted to make sure that they know up to 99% accuracy exactly how much of a particular product they have in a store and just where it is. It was going to solve a subset of problems, but when we started piloting there, getting all sorts of different ideas. For example, they have situations where, so they have associates, people who help others around in the store, keep it neat, stock products in shelves. So they have a problem where, just like us, we try on something, we drop it off somewhere and walk off. So what happens is these in turn become hidden products. Why? These products are not. So if I go looking for a specific shirt, so how do you solve these problems? So they start putting new problems in there. And for example, they would want to know, hey, every morning when I come in, I need to know where our misplaced products are and where I should take them. Now, say that we developed our entire ecosystem just canning ourselves to the only problem of figuring out, providing, let's say, user interface, which says, okay, you have this many products in your store, and this is where they are located. That's the only way we get this to be able to support other use cases. So here, what we're doing is we're basically making our data generically available. It's very associated with the IoT space as well, because when you come up with so much of data now, here we have RFID data and their locations. So when this data is exposed to other applications, there are so many other use cases that can get built on top of them. So the idea here is that you don't, when you're building something, let's say, especially when it's collecting data, do not close it. Do not close its operations. Say, our system to not be able to access commands from the outside, to sort of not expose an API to be able to remotely control it, we may reduce our use cases. We may have to go way back in order to redesign our system to right. And so I'll give you a very recent example. We had a situation where now, Google Street View, right? They're trying to create a scenario where you create an aisle view. So So this is something that a customer wants. You fix in a 4K 360-degree camera on top of the robot, and while it's also recording video footage. Now, this requires, now the use cases are this. Interior designers can at any time look at the store and figure out, okay, we need to change this around. You can create lots of applications, you know, this the VR gear that's coming around today. You can create so many different experiences today. So these are things that retailers are trying to tell. Now, a very important thing is we had exposed an API enables to track where the robot was at any given time within a store. But this didn't really have any correlation with our original use cases, which was identifying RFID locations. Now look at it, if we didn't have this information, would someone be able to correlate that video footage to an actual location in a store? So this is the sort of extensibility that we need to get an ecosystem that supports extendability of robotic applications within, let's say for us it's retail store, but I think wherever we are planning on putting robots out, this should be the case. So like looking at just to action of robots, we are also testing human if those APIs are exposed to a certain level where someone can start programming them. Someone can start developing their own applications on top of them. The utility of robotics gets extended and increases so much more that it's when applicability increases, the ability to sell something also increases. So that is what I meant by deployability, making it painless. So technology should get out of the way. Adding technology should be additional burden. And at the same time, creating an ecosystem for extension is basically probably a big set of words to say that whatever data you have, expose it. We'll comes into that.
Thank you. Mr. Anurag, what do you think about open source hardware? What's the impact of it in global sense as well as in Sri Lanka?
Okay, so I think it's fair to say that in the last 10 years or so, all the concept of longer. I think ever since there was research possibly. This notion of open source hardware has really taken pretty much the world by storm. I think what Professor Nali was talking about, the Arduino and all these other examples of open source hardware. The whole primary thing of it is being that manufacturers not only provide the hardware, but also the specs and the detail and the rights to actually modify and extend your hardware as well as to redistribute whatever changes that they have built on top. These are very strong and very powerful concept. Almost the concept of Linux and free software, add-on software. I think we see the open hardware movement take place in hardware, which is fantastic, because if you look at any enterprise today, which enterprise does not use free software, open source? I don't think you'll be able to find any enterprise out there that does not use open source in some form or the other. Linux, Apache, whatever, right? So similarly, with this whole concept of hardware being open and media being open, and folks building up on top of each other's work, you're going to start seeing a snowballing effect, and innovation continues on, and that helps economies like Sri Lanka, because we need things that are open because of the state of and all those other things. Plus, I think as a nation, I think it helps for us to also start thinking in terms of open hardware, because traditionally, when we build a product or build some kind of solution, the first thing that comes to our mind is, how do I patent this? Or some form of patenting or restricting of IP so that you can get maximum benefit out of it. But I think by doing so and by taking such a litigation-focused approach, now I'm a little biased when it comes to patents. I think it actually hinders innovation more than it actually fosters it. So in that sense, I think things being open would actually improve innovation. And as a community and as a country which needs innovation, I think we really need to start thinking about it. Because we're more of a very consumer-driven society. I think with these technologies and these concepts and open hardware, I think it will help us to become more of a manufacturing or kind of community where we're not actually consuming stuff as well. I think open hardware and ecosystems and all the other things that definitely help. Just taking my personal story, because of open hardware and because of open software and all these, it was very easy for me to catch up on these technologies. And I think it really helps someone trying to learn this, when things are open and things are available. And with MOOCs and just-in-time learning easily available on the internet, now is a better time than ever to actually get into this technology space as well.
Thank you. In the third round, I can accommodate the limitation of accommodate maximum of 3 questions from the audience. It's your time.
I would like to know whether talking about rehabilitation and your robotics is using rehabilitation therapies. Are there any robo-aided assistants available here in local market? For instance, let's say physiotherapy or something, to make the patient mobilize. Do we have any robo-assisted physiotherapy devices?
It's the best person. It's the specialist.
Actually, so actually, my area is rehabilitation and assistive devices. So we have been and we have done a few researches to develop low limb exoskeleton robot, which can help the therapist and also which can help the patient. But directly answer you, in the local market, we can't see any device, such kind of device. But in the foreign market, especially in Japan, there are such kind of devices. I can name I did that institute in Japan, which can assist the low limb motion and which can help to the rehabilitation. Such kind of devices are in Japan, but not in local countries.
Thank you. And though I leave the number of questions, please the restriction of the number of questions. You can ask 1 or 2 questions. You have time.
Now all those robotic system, based on electricity and also the airplane models that shown by Professor Rohani. Sometimes the flight time is around 20 minutes, and also most of the drones that those robotic devices we can see nowadays, the charging time is all those devices. The batteries are around 3 or 4 hours, but the operation time is limited to 20 or 30 minutes, sometimes very limited. How to face that problem in the near future? I mean, also we need to spend more time with the batteries. The problem is basically with batteries, so, and also energy sources. So at least we need to spend a lot of time for charging. but the operation time is very limited, very especially for the remote control devices. So, what are the any way of facing in future?
Uh, I think the answer is you have to select the right propulsion mechanism for the mission. If it is a five-minute kind of mission, you can run off batteries, and you don't worry too much about the efficiency or whatever. But if it is let's say you want to map an area about let's say 10 square kilometers, go to fly probably, you can't use batteries. You need to go for an engine. So that is why we have a battery version and petrol version, engine version. In battery version also, even though I say 20 minutes, that is 20 minutes flight time. If somebody asks me, I would say 20 minutes, but that is not perfectly correct. Most of the power is used for the taking off after kind of easy ride, cruising. Then it is much more energy efficient. It's very much like driving your car on traffic and on highway. More kilometers a liter if you are cruising. So therefore, our estimate is that if it is a short mission, the sea mapper I showed you in the last video, you can fly it every 20 seconds. The battery drops by 1%. But if you use it for a long mission, every 30 seconds it drops by 1%. So it's more efficient. It's like that. So if you think of a long flight time, even longer, then you can think of, let's say, long sails, like gliding, using probably you can use solar charging while you are flying. So you have to use proper combination, proper propulsion and system for the UAV.
Thank you, Professor Rohan. This is the opportunity for the final question from the audience.
So IP version 6 technology is out there, and probably some industries has already started working with that. And what would be the application for IoT devices right now? So, for example, how soon I can use my Raspberry Pi working on my IP version 6?
Yeah, actually, the good thing is like IP version 6 can be run in par with IP4 also. Like for example, if you can configure router to an IP6 or IP4 version at the same time. So that's a good thing. The thing is because countrywide we have not deployed the IP6 version yet, so we can't use because like if you can expand your network, which all routers supporting IP6, so whole network you can cover. But if you can want to move to like IP6 to IP4, then you have sort of restriction. But there are some things like you can have some sort of protocol that like like earlier like when we start off internet, like we had AOL and other things like CompuServe and other email systems, which is not internet. So you can have some gateway like that. Maybe you can have some IP6 network. Then you can have gateway to maybe tunnel to another IP6 network, and from there you can. But all these IP6 devices has to be connected to IP6. But Sri Lanka currently no one supports IP6 yet. But when it comes to IoT and if they all really need the real IP, like we are now using not real IP, which is registered network or like chain network or whatever it is. So these are sort of dynamic IPs assigned by your DHCP server load. Right? So these IPs are working like IP version 4. Then you have something called network address translation net, or like what some other protocol which will convert to IP4 network, real IP and basic setting. So like that you can have sort of IP6 versions also like deployed inside your network and it will work very efficiently. But if you want to send it outside, convert to IP version 4 because other network routers doesn't support. But basically, when it comes to IoT, to get like real IPs, then you have to go for these IPs. Because I mean, address space will be fixed.
Thank you, Rani. A question session from the audience. You have enlightened with the basic classification of the robotics. This is some sort of academic aspect of the robotics. Then we discuss about Internet of Things in the presentation also. Then thereafter we talk about open source hardware and how then ecosystems, how it is applicable to extended to robotics. We have enlightened these aspects. Still, robotics long way to go. Though there is a remarkable development, then this is in your hands, right? I expect you can proceed and you have the guts and energy to drive it. And I would like to thank the four panelists for serving here and share their knowledge with you. Thank you.
We have arranged some gratitude ceremonies for all the panel members as well as today's speakers. So I would like to invite Dr. Ruwan Tokuda, who is the Secretary of IEEE Robotics and Automation Society, Sri Lanka Section Chapter, to give away the souvenirs for today's speakers and panelists. We would like to invite Professor Rohan Munasina to receive the souvenir of gratitude in behalf of the organizing committee. Then I would like to invite Engineer Nari Karnasinghe to receive the souvenir. Dr. Sanat Jayawardena to receive the souvenir of gratitude. I would like to invite Mr. Anurag Deevan, the panelist, to receive the certificate. Here I would like to invite Mr. Keshan Pereira to receive the certificate. Now, I would like to invite Dr. Ruwan to deliver the vote of thanks.
Good evening, everyone. So I hope that you all got very fruitful and informative presentations and discussion. So actually, before going into the work plan, I'd like to add few things for his question. Actually, few non-active, we call passive devices are there in Sri Lanka, also you can also SLS bureau and Ragama Rehabilitation Center. If you go there, you can see those devices, but we can't tell them as robotic devices which assist for the rehabilitation, right? So going into my duty, I think this is a good initiative in robotics in Sri Lanka. This is the first of event in this nature. Robotic and Automation Society in Sri Lanka, we actually are the first such kind of in here. Our parent section is IEEE Sri Lanka section, and our main body is the Robotic and Automation Society law. Right? So we initiated the Robotic and Automation Society 3 years back, and doing a few. We have done few seminars, workshops,
with international conferences, one Mobility Research Conference and ICIA Test Conference. And we have done several PLCs. We have got several and some textile-related companies. And also, this is the first time we have done this kind of meetup. So going into my main duty, out of 10, actually this meetup began 3 months back. I would like to mention the name of the person who initiated this one. It is Mr. Raju Adhikari. Can you, Mr. Raju, we would like to thank him first, and can you round of applause? He's actually the leader of this meetup. He's also a member of Robotic and Automation Society. Thanks. Right? And then I.
Thank you. Without you, this won't be a. Because of you came here, the event becomes success. And I would like to thank also the presenters and the panel members, and who moderated the panel, and finally to the who library society. Thank you very much.
So that makes my work easy. But, so and I don't want to thank Rohan and Narin Kanofina and Perra, so on 24/7, and person member of your family, Mr. Anuradha Viraman. And also I would like to thank all the participants and person in the Versa. And I would like to mention few names from the Versa. Madhu Ratnayaka, Executive Vice President, Head of Digital. President, Head of and we will have this kind of meetings annually, and we have put this Robotic Meetup to the annual calendar of Robotic and Automation Society. Near future, we will have such kind of events. I'd like to invite you for those kind of events. And thank you very much. Can you give a big round of applause to participants? And
thank you very much for all of your participation. And now we would like to wind up Lanka Robotics Meetup now. And we have arranged some refreshments. And now I would like to serve you as thank you.